Hello everyone, today we will try to solve this question about Newton's cooling law. So in this, of course, it's about applications of ordinary differential equation. First of all, let's read what it says about. We will try to solve eight first question. It says that container holds 1 kilogram of water at 20 degree. Half kilogram mass of aluminium is added at 75 degrees. The heat capacity of aluminium is 0.2. In 1 minute's time, the water is warmed 2 degree. When did aluminum cool by 1 degree, and when did the water warm by 1 degree? It also has stated that assumes that the water loses no heat to its surroundings. Says that the specific heat of aluminium is 0.2, means that 1 kilogram of aluminium contains as much heat as 0.2 kilograms of water, and it is also in upper part. Let me show this part of this. It shows that in 8 and 8.2, in problems 8 and 8.2, one must use Newton's law of cooling, which says the rate of change of temperature is proportional to difference of temperature between cooling body and its surroundings. Let's try to solve. I have already solved. I won't show you my solution to you. So if I have state the environment as surrounding, which in our case is 1 kilogram of water. It is in 20 degree, and cooling body is aluminium. It is 75 degree, and its mass is 0.5 kilogram, and our heat capacity is 0.2. Of course, it's for aluminium, and and it's also stated after 1 minute, it is water's heat has degree has its degree increased 2 degree, and it has became 22 degree. And let's write what's Newton's law of cooling. As you see from here, I have already written Newton's law of cooling. It says I have written that a change of degree of cooling body, which is respect to t, respect to the time, is directly proportional to the difference between cooling body and its surrounding. It's directly proportional, and you can be interesting that what is why is k is minus, because as we know, when it is something is cooling, it is degree is decreasing, therefore it is, and derivative will be negative. Therefore we are adding minus in front of k in order to keep k positive. And it is we are lucky that is separable equations, and we are solving this separable equation. And you know, as the first the cooling body aluminium is 75 degree and environment is 20 degree, and and so 70 we are after we are finding t minus the environment is equal, we solve this, just it is normal separable equation. We are finding ln, and uh, and this is my case integral respect to t is minus kt. So for t0 we are just plugging in everything. It 75 minus 20, and here is t equals 0. Therefore your power 0 is 1 times c. We are finding c from here, and after our equation becomes like this. Now let's look at another side. Heat capacity is directly proportional with mass. We know this from physics, our physics course, and it says that it was saying that 1 kilogram of aluminium contains as much heat as 0.2 kilogram of water, and it means that 1 kilogram of aluminium contains 5 times less heat than water. It means that 0.5, but we have 0.5 kilogram of aluminium. It means that 0.5 kilogram of aluminium contains 10 times less heat than 1 kilogram of water. Then let's try to find K. As we know, after 1 minute, temperature of water increased 2 degree and it became 22. And we already we already stated here, water's heat capacity is 10 times more than aluminium. So if it increases 2 degree, aluminium in a 1 minute should decrease this temperature 10 times more. Therefore, after 1 minute, degree will be 55 degree. For t equal 1 minute, let's solve our equation in order to find k. We are just plugging in everything in this equation. You see this part. This part we are solving and we are finding k, and as you also see from right side of our equation, it becomes like this. Instead of k, we are plugging in here our equation, and in front of k there is one minus, and the two minus becomes positive. As we also see from right side, it's always positive number, because f over something is always positive, and multiply positive number. And it is asked us, when did aluminum cool by 1 degree and when did water warm by 1 degree. It means that difference between them, absolute value of the difference will be always 1. Therefore, we are putting, instead of T minus T environment, 1, because if it is cooled by 1 degree, there will be difference 1, and we are just solving our equation, and answer is 7.8 minutes. Thank you for watching.